Okay, on the first question, they're asking us to find two positive numbers whose product is 161 and whose sum is a minimum. So I'm just going to use x and y for the two positive numbers. Product means that we multiply, so x times y would be 161. And then the sum would mean that we add, so our sum would be x plus y. So we're wanting to find basically the minimum of that sum. So in order to do that, we need to have an equation that is in terms of just one variable. So I'm going to choose to take this first equation and get the y by itself so that I can plug in terms of x. So if y is the same as 161 over x, then in this equation here, I will replace the y with that value. So now basically, we're just trying to find what is the minimum of this particular function. So in order to find that minimum value, we have to take the derivative. So we'll pretend like this is your f of x function. So we're going to look for the f prime of x. So the derivative of x itself is just a 1. And then, of course, I would rewrite this here as 161 times x to the negative first. So I can just do the power rule. So using the power rule, when I pull that negative 1 to the front, that's actually going to make that a minus. So let me get rid of my plus there. So that'll be a minus 161. And then when you decrease that power of x by 1, that becomes x to the negative 2. So we need to set that equal to 0 so in order to find that critical value. And it might help to go ahead now and just rewrite this as 161 over x squared, because that's what that negative power means. And then if we move this term to the other side by adding it, so we add it to both sides, then at this particular point, you have the equation where 1 is equal to 161 over x squared. And so we need to get that off the bottom, the x squared. So if you multiply both sides by x squared, then that just turns into the equation where x squared is 161. And in order to find x, we would square root both sides at this point. Normally we'd consider both the positive and negative, but because they specifically said positive numbers, we're only going to look at the positive square root. And you can't really simplify the square root of 161, so we're just going to leave it as the square root of 161. So there is one of my positive numbers. And then if you were to plug that back in here to this original, you would have the square root of 161, or actually you could do it down here in order to find your y. If you take 161 and you divide by the square root of 161, you actually get another square root of 161. And so both of the positive numbers are square root of 161. Okay, on the next equation, we've got a company who manufactures and sells cell phones per week. They're going to let x be the number. And they give us the weekly price, demand, and cost equations here. So on the first part of this, we're going to be looking at revenue. So we need to know that when you calculate revenue, you have to take the price. And so they've given us that P equation right here. So we have to take the price, and we have to multiply by the number that we sell, which they told us to use x. So I'm going to go ahead and distribute that. So that becomes a 600x minus a 0.5 times x squared. So because we're being asked to maximize, that tells us we need to take a derivative of that. So under part A, I'm going to derive my revenue function. So the derivative of 600x would just be 600. And then we have minus, we have our 0.5. When we pull the power of 2 to the front, that'll be times 2. And then we decrease that power by 1. So what we actually have here is we have a 600 minus, when you take 0.5 times 2, that just becomes a 1, and then times your x. So in order to find critical values, we then set that equal to 0 and solve. So 600 minus x, if that's equal to 0, and we add x on both sides, that's telling us how many cell phones should be sold. So that's going to be the answer to that question. How many should be sold? And then, of course, they also wanted to know what is that, or what price is going to maximize that. So then if you go back to your price equation here and you plug in, the price would be 600 minus the 0.5 times your x, which is 600. So that gives me 600 minus 0.5 times 600 would be 300. So the price is $300. And then they also asked me what is that maximum weekly revenue. So then we also plug our 6 into this revenue function here. So my revenue would be 600 times my x of 600 minus my 0.5 times 600 squared. And then, of course, at that point, I would just do the number crunching on a calculator. And so when we plug that in, you're going to get a revenue of $180,000 for that part. Now, as I go to part B, they're going to be talking about the profit. And so before I flip to the next screen, remember your profit is equal to your revenue minus your cost. So my profit is my revenue minus my cost. And so when I look at, so for my profit, for my revenue, I have this. And so for my cost, I have this. So when I flip to the next screen, I'm going to take my revenue function, which is this, and I'm going to subtract my cost. So my profit is equal to, so the revenue was the 600x minus the 0.5 times x squared. And then you have to subtract your cost. And because it has more than one term, I'm putting it in parentheses so that I make sure that I subtract both parts of that cost. So the cost was $25,000 plus 140 times x. Okay, so if we go ahead and clean that up, I'm going to pull the negative 0.5x squared to the front. When I take the 600x and I subtract the 140x, that is going to leave me with 460x. And then, of course, when I distribute that minus to the 25,000, I get minus 25,000. So there's my profit equation. Now we're trying to maximize profit. So anytime you hear those words, maximize, minimize, that's just telling you you're finding a derivative. So now if I take the derivative of my profit equation, I have negative 0.5 times, pull that power of 2 to the front, and then decrease the power by 1. And then plus the derivative of this 460x is just 460. And then, of course, we set that equal to 0. Negative 0.5 times 2 would make that a negative 1x. So plus 460 equal to 0. I'm going to move x to the other side, save myself some steps. So there is the number of cell phones that have to be produced. So that answers that question, how many should be produced? And that is 460. And then they wanted to know what price should be charged. So you got to go back to the very original where they told us that the price was 600 minus 0.5 times your x. And you got to plug in there. So 600 minus 0.5. This time my x is 460. So that would be 600 minus half of 460 is 230. And then when we subtract that from 600 minus 230, we're going to be left with 370. So there's the price. And then finally, they wanted to know what is that profit. So now you're plugging your x in here. And I would just, at that point, get on a calculator and let it do all that squaring. So plus 460 times 460. And then you have minus your 25,000. And so when we plug all that in, then your maximum weekly profit is going to be $80,800. All right, last but not least, we have a car rental agency. They're renting 440 cars per day at $20 a day. It says for each dollar increase in rate, 10 fewer cars are rented. So, and we're going to try to be maximizing the income. So I'm just going to call it I for income. All right, so if I let's look at price first. We know that $20 a day is what they're basing it on, and we're trying to look at how many dollar increases are going to result in fewer cars being rented. So we're going to say X is the number of dollar increases. So that would be a variable expression for your rate. And then, of course, what happens is if it were $20, they'd rent $440, but every time they increase that rate by $1, they are renting 10 fewer cars. And so if X is the number of times they do that, then we would now have the expression of 440 minus 10X for the number of cars that they could rent. All right, so we're going to try to, or they're asking us to find or try to maximize the profit. So we're going to need to find a derivative. And I think in this case, instead of doing the product rule, I think I'm going to go ahead and FOIL it, and then it just makes it easier in the end, just doing power rules basically. So 20 times 440, you're going to get 8,800. And then you're going to get plus a 440x. And then you're going to have minus a 200x, and then you're going to have a minus 10x squared. So I'm going to put my terms in order. Pull that negative 10x squared to the front. 440 minus 200, that is going to leave me with the positive 220x. I'm sorry, 240. 240. Positive 240x. And then I have plus 8,800. So now we're ready to take the derivative of that income. So just doing power rules, negative 20 times x plus 240. And then we, of course, set the derivative equal to 0 so we can find that critical value. And so I'm going to move the 20x over. So 240 equals 20x. And so if I divide both sides by 20, then I'm getting a value of my x is equal to 12. Okay, now we've got to answer the question of they want to know what is the rate, and then, of course, what is that maximum income. Technically, you probably should test this to know that it is where the maximum occurs. You could do a second derivative test. I'm just assuming when I find it that it is going to produce the maximum, but you probably should test it. So if I go back to my, look at my rate of $20 per day, so $20 plus my x is 12, so I'm going to have 12 of those dollar increases. So that means that I'm going to be at a rate of $32 per day. And then they want to know what is that maximum income. So now I'm going to plug my 12 back into here. And so I'm going to get negative 10 times my 12 squared plus 240 times my 12, and then plus 8,800. And again, I would just do that number crunching on a calculator. And in this case, they're going to be having an income of $10,240 per day. Now, they never asked how many cars it would be, but if they did, then you're simply going to be plugging that into this part of the equation, and that would tell you the number of cars. But this is what they asked for, not the 12. They asked for the price and the maximum income.